Okay, so if you're asked to find the distance between a line and a point in 3 space, I'm going to show you how you can do that using a cross product. So let's say our line is given to us in parametric equations. So I have my x, y, and z components. And then I have a point out in 3 space. How will we find the perpendicular distance between them? And the reason why I would say perpendicular distance is that's just going to be the shortest distance between the point and the line. All right, so when our line looks like, right, parametric form, then we can certainly find a point on the line, right? So down here I've got my line drawn. I've got my Q out here in space, so Q is right 0, 2, 6. So this point P, remember those are just the constants in your parametric form. So my point P is going to be -1, 5, 3. The T coefficients in your line, right, that's your direction vector, right? And that's telling you essentially the slope of the line, what direction is it going. So I'll write that here. So that's, I'll call it vector V. So vector V is going to be -8, 8, 4. Well, for the picture here, and try not to get too hung up on the, am I going left, right, up, down, whatever, right? We're just going to flatten it down here to my plane. The distance I want is this, right, perpendicular distance here between Q and the line. I don't know what that is. What I could find is I could find the distance here between P and Q for sure. Right? And before I do that, let's go ahead and let's find that vector. Let's find that vector and we'll call it U. So find the vector from P to Q and call it vector U. So vector U is going to be, so 0 minus -1, 2 minus 5, 6 minus 3. And so what, right, I could find the length of vector U if I wanted. Well, here's my theta. V is the direction of my line, right? So I could have a vector V down here. And I don't know about you, but I'm seeing some right triangle trig screaming out at me. Okay. So let's start with this. So let's say sine of theta equals, right, D over the length of U, right? So sine is a ratio of the length of sides of the triangle. Well, okay, well that doesn't really help me, but okay. Multiply both sides by the length of U. So distance, the thing I'm actually after, I'm going to get rid of both of my things. I'll just use my absolute values for length. So length of U, right, times the sine of theta. Okay, so far so good, except I don't know what theta is either. But, and here's where it gets kind of a, well, how would you know to do that? And it's, right, somebody was just messing around and said, hey, look what happens. And we're benefiting from their, hey, look what happens moment. If I multiply both sides, I'm going to do the same thing to both sides, okay? Multiply both sides by the length of V. Don't worry about the left side for now. But look at what that right side is. So now I have length of V times D for my left. Who cares? I'm going to rearrange my right. Got length of U times length of V times the sine of the angle between them. Well, does everybody remember from your cross product days that length of U times length of V times the sine of the angle between them is just the length, right, of the cross product, U cross V. So my right side is actually the length of U cross V. Well, that I can find because I have, right, I have a U vector, I've got a V vector, so I can do that. And then, right, so that's V times D. For the left, I only wanted D, so we'll divide both sides by the length of V to get my formula. So if you are a card making person or a note, right, you keep a notebook with all your formulas, this would be one. This is the distance between, right, a point and a line where, let's see, V is the direction vector of the line, and U is the vector, right, between the point on the line and the point in space. Okay. All right, so now that we know what we're supposed to do, let's just go ahead and do it so we can actually find it. I'll change colors here. Hopefully it will show up. Okay, so I need U cross V. So we'll go ahead and set up that. So I, J, K. So my U vector 1, negative 3, 3. V is vector negative 8, negative 8. I'm sorry, negative 8, positive 8, 4. Okay, so do your expansion. So I, negative 12 minus 24. Plus J, I'm going to go backwards, negative 24 minus 4, and K, 8 plus 24. You guys are watching my math too, right? Making sure I didn't make a mistake there. So 32. So there's U cross V. I just need its length. So we'll find the length of U cross V. So 36 squared. Since I'm squaring, I'm going to leave off those negatives because I don't want to deal with those. Oh, and my pen's about to die. Grabbing a new color. Pausing and grabbing my calculator. So the length of U cross V is the square root of 3104. Yikes. So now we need the length of V. I know my notation is not very consistent. I should be using double brackets whenever I talk about length. I should be putting arrows over my vectors. It gets really cluttered when I'm trying to write, so I don't always do that. So the length of vector V, where's my vector V again? Up, all the way up here, negative 8, positive 8, 4. So square root of 64 plus 64 plus 16. We're at 144. Okay, we'll just make that 12. So the shortest distance between my point 026 and the line given parametrically above is square root 3104 over 12. Doesn't it seem like the square root of 3104 should be nice? Nope, it's not. Okay, there we go. There is the shortest distance, right, between that line and that point.